this lesson, okay? Where I want to take this is we're going to actually talk about this handout now, okay? So I want you to pull out this handout. Now we're going to be talking about SAT 2s and using the TI-84 graphing calculator. So when I originally talked about putting this the original lesson together, the first lesson that I just did, Mrs. Wang asked me to put together also a discussion on SAT 2s and graphing calculators. And so I got to thinking about, so how do I really want a student to use a graphing calculator? Do you need a calculator to take SAT 2s? The answer is yes. You do need a graphing calculator, and the reason, well, it doesn't need to be a graphing calculator, but at the very least it needs to be a scientific calculator. And the reason why is because some of the questions on the SAT 2s are going to be giving you solutions that are estimated answers, and you're going to need, at the very least, you would need a table. You would need a log table, you might need some trig tables and things like that, but those aren't as popular as calculators, and you can go to Long's and buy a scientific calculator for $12 and be prepared to take the SAT 2. But here's one of the things that I always like to say to students when I'm doing SAT prep work, is that if you use a calculator, there better not be any arithmetic errors, right? So there's no excuses for adding something up wrong or multiplying something wrong or dividing something incorrectly. Use your calculator so that you at the very least eliminate arithmetic errors. Another thing is that a calculator, if you don't know how to use the calculator, I can almost guarantee you that the calculator will cause you a lot of trouble during the test and waste a lot of time if you don't know how to use your calculator. So if you're going to use a calculator taking the SATs, you'd better be very well practiced in solving problems on your calculator so that you're not trying to learn how to use your calculator at that moment. So make sure that you're using it. So the ways that we're going to be using a calculator in the SAT 2s, you'll need it to find trig values and to solve trig functions. You're also going to be needing it for inverse trig functions. So you're going to be given a ratio, and you're going to be expected to know the angle. And you're also going to be expected to know the difference between radians and degrees as you're solving those, and as you're looking for rounded answers. You'll need to take the higher order roots of numbers. You'll need to find higher order roots. You'll need to solve exponential formulas and compare results when inserting different values for the exponents. It'll also become useful for counting the number of intersections of graphs plotted on the screen. So what I ended up doing in preparing for this discussion here is I went online and I actually went to College Board and I took the SAT 2 for math and just did them all. And I said, okay, how many of these questions? And by the way, I went to a site that talked about, did a whole discussion on graphing calculators and the SAT 2. And one of the comments that I found out at that site was that at least 50% of the problems, 55% of the problems will require you to use a calculator in order to be successful. So you better have at least a scientific calculator, if not a graphing calculator, handy, and you must know how to use it in order to be successful in the SAT 2s. What else will you need to know in addition to a calculator? Let me kind of go down that really quickly. You'll need to know your trigonometry, both in degrees and in radians, and you'll also have to know special right triangles is always a good thing to know. So 30, 60, 90s, 45, 45, 90s. Better have those values down, right? You'll need to understand what properties affects the graphs of rational algebraic expressions. And by that I mean, if a graph is going to require having a vertical asymptote or a horizontal asymptote, you'll need to know what different parameters there are in what we're using in order to get the identity of an asymptote or even a discontinuity. And you'll need to even know what a discontinuity is, possibly a removable discontinuity related to a rational expression. You'll also need to understand how to manipulate a matrix and perform operations on matrices, and understand whether you can or cannot perform different operations on matrices. And you also need, especially, to know how to factor algebraic expressions. So those are things that aren't going to require a calculator, are they? And so you're going to want to know how to do those and know how to do those well. So here are the examples then. I pulled out, you know, of the 30+ questions that were on that sample test. I copied and pasted them in here, and let's talk about how to solve some of these. So for example 1, down at the bottom of the first page, it says a number n is increased by 8 if the cube root of that result equals -0.5. What is the value of n? So let's figure out how to do that. The question says a number n is increased by 8. So we can just simply say n plus 8. If the cube root of that result equals -0.5, what is the value of n? So another way of saying that is solve for n, right? So hopefully you can do this. Actually, so in your calculator, I'm going to have you use this key sequence. We're going to go parentheses n plus 8, and then I want you to use a hat in parentheses 1/3. That's how we get it to the third root. Okay. So that, and then and actually, in order to do this, there's actually some manipulation you want to do on paper before you actually punch it into the calculator, right? So let's back out a little bit. This is what I really want you to be thinking on your paper, is that you're going to take you're going to take both sides to the third power. So on the calculator then, you're going to be doing this. Parentheses, -0.5, and you're going to do hat 3, and then hit enter. So if you do that, hit quit if you're still in graph mode. Parentheses, -0.5, close parentheses, hat 3. What do you get?
Error.
You got error? Did you get that? That's what you should be getting. We may have to reset that calculator if that's giving you an error. Okay, and then from algebra, you know that we could just subtract 8 from both sides. So we're going to subtract 8, and we end up with n equals -8.125. And that's the answer to number 3. So you see that one we're going to have to take something to the third power in order to get that, and that's how that problem works. Let's flip the page and go on to the example 2. In example 2, number 11, in the figure above, ABC has a right angle at C. If the length of side AC is 10. So you can go ahead and write those in. I give you a triangle like this. And they said this was 10. And the measure of the angle at BAC is 22 degrees. What is the side length of BC? So this one's going to require that you know your trigonometry, right? Which trig is going to work for us here? Not law of sines. Tangent is going to work here. Okay, so let's just call this n for now. And couldn't we say it this way? That the tangent of 22 is going to equal n over 10. Okay, because that's the definition of tangent, right? And so if that's the case, the calculator can give us the numeric value. Now, we also have to make sure that, hit mode key and make sure that you're not in radians, but you're in degrees. So highlight degrees and hit enter. And then let's get out of that. Hit tangent of 22. Tangent of 22. Hopefully you got 0.404. 0.404 is equal to n over 10. So we multiply both sides by 10. That moves the decimal place over by 1, and I end up with 4.04 equals n. So there's using the graphing calculator that way. Example number 3 is number 14 from the test, and we're simply going down that list. Rectangle ABCD is inscribed in a circle shown above. Actually, you know what? I want to skip this one. Where I really want to go is, let's go to example 4. Because really what I want to focus on is the idea that we have a graphing calculator, and they allow us to bring a graphing calculator in here, because so the SATs allow you to use a TI-84 in the test. And if that's the case, then let's use the functionality of the grapher, right? Example 4 is a question that says this: f of x equals x to the 4 minus 3x to the 3rd minus 9x squared plus 4. Okay, hold on a second. And how many, and so the question is saying, for how many real numbers does f of k equal 2? Are you seeing that? This is saying f of x is equal to x to the 4 minus 3x to the 3rd minus 9x squared plus 4. So the question, it's on the paper. Yeah, it's on. So for how many real numbers does f of k equal to 2? On the grapher, let's do it this way. I want you to hit y equals. So you're going to hit the y equals key, and then you're going to enter this into the grapher. Okay, so hit clear so that we're clearing the y1, and enter into it x hat 4, right arrow, minus 3 x hat 3, right arrow, minus 9 x hat 2 plus 4. Whoops, right arrow plus 4. plus 4. And if you enter that in, you should see something that looks like that. Okay? Actually, I'll take a picture of it and show it to you.
Can you graph it?
Yeah, we will. So that's what it should look like right there on your grapher. If you hit graph, we're not going to do that one yet. We will. We will. Okay. No, we're not going to go there right now. Okay. I'm going to reset my window for this as well. Okay, my window that I want you to use, I'm trying to think of this one. I think what I really want to do is go from negative 20 to positive. So x min is going to be negative 20. Let's make x max 20. Let's make y min negative 40 and y max be 50. And then hit graph. Okay, it looks like I can narrow that a little bit. So instead of negative 20 to 20, let's make it negative 10, positive 10. Okay, and we can actually, from there I want you to zoom in. So go ahead and hit zoom in. And let's just let it zoom in where it wants to. Mine's saying let's zoom in on x equals 0 and y equals 5, so hit enter. And if you zoom in, now we start to see a graph that looks kind of like this. Actually, you know, I can make that line wider too. This is something that I learned as I was looking at this. When you're in the y equals, if you hit the left arrow key so that it ends up hitting that line, you'll see the line flashing next to y1. Hit enter, and it changes the line. So the first time you hit it, it's going to be a thicker line. The second time you hit it, it's going to be a shading up. The third time that you hit it, it's going to be shading down. Fourth time you hit it, it actually has a moving dot as it draws it. Then there's a moving dot where it doesn't draw it. Then there's dotted lines, and then back to the start. So I want you to go for, I'm going to do the thicker one, and you'll see that my graph now is a thicker line. That's kind of a cool functionality, isn't it? So there's that. Let's do this. We're going to go back to y equals. So go back to y equals and go to y2. And at y2, I want you to hit the number 2 and enter. Because what we're doing is we're saying I want to also graph y equals 2, and which is going to be a horizontal line passing through y equals 2. And where does that line cross our original function? It's going to draw it for us. And then all we have to do now is count. So now our picture looks like this. And now we're realizing the power of what we get with our graphing calculator when we're able to do that. So with the graphing calculator, now it's as simple as this. To answer the question, they're saying how many real numbers does k, real numbers for k are there so that k is equal to 2? Well, now it's just looking at you, right? Because here's one of them. There's another one. And there's another one. And guess what? That's not all. Because we didn't go wide enough. We're going to change our window so that we go x max at, I'm going to say 20. And what you'll notice is that it actually passes through a fourth time. So I'm not going to go for 20, we'll go for 9. So now my picture looks like this. get rid of this one. And now you'll see there's 4 places. So we counted this one, 1, 2, and 3, but we didn't think that and hopefully you'll know enough about polynomials to know that we had a 4th degree polynomial. So it's going to come back up from where it came. It started out high, it went down, it traveled around a little bit, and then it went back up to high. Okay, that's a 4th degree polynomial. If it was an odd, then it would go from low to high, or it would go from high to low. So you have to understand the difference between even and odd functions in that. Since it was a 4th, you should have expected it to come back, and sure enough it did. 1, 2, 3, 4. So the answer to that question is 4. Is a graphing calculator useful in the SAT 2? Yeah, on that particular case it really is, isn't it? Okay. I think that that's where I want to stop right here. There are other examples, but I think that that was the one case where the graphing calculator comes in really handy, because you're able to use the graphing functionality to answer a question on the SAT 2. Okay? And so thank you very much for coming and hearing this discussion on graphing calculators. If you have questions or want to show me something that you were able to do on a graphing calculator, I can stick around a little bit and we can talk a little bit. If you